identify different type of differential equation. We look at this example, this first example here. Right, what we see is, of course, we have the dx and dt, and usually when it is written in that form, it is going to be the exact equation or the homogeneous equation, those kind of things. So if we take the derivative of this with respect to the different variable than dx, so let's take respect to t, you're going to have 4x, and the derivative of this, we have t already, so we're going to take the derivative with respect to x, and it's going to be 4x. So it is exact equation as well, but that's not what we asked to find here. Right. Right. What we only have this option. So next we go to, is that Bernoulli equation that difficult to determine, so we do that later. Uh, it is not going to be in the form of ax plus by, so we know that's not going to be this, because we have x squared to x squared plus t squared, so it's not going to be that for sure. Now we look at the terms. Look at this, we have t to the first power, x to the first power, so the total of them, it is the degree 2. Now we have the degree 2 here and the degree 2 here. All the degrees are the same, so that's why it is homogeneous. So I'm going to check this box. It's going to be yes on this box. Right. Next, linear coefficient. It's not going to be linear coefficient either. So now we check for Bernoulli. That is a little more difficult, but what I do is just multiply this out, and now we move the t squared dt on the other side. Now, the Bernoulli equation, we change that to the standard form, so I will divide both sides by 40x dt, 40x dt, 40x dt. By the way, this is a null here also. So cancel and everything, and we have dx over dt, and here we have 2 over 4, which is 1/2. We have an x on the top and t at the bottom. Dt cancel out, 1x cancel out, that's what we have. And on this side, the dt cancel out. The and the x still there though, so we have negative a t divided by 4, and then x to -1. So that's what we have. If we move the x to the top, it becomes x to -1, right? So now we just rewrite this just one more step. Dx over dt plus 1 over 2t x, and negative t over 4 x to -1. And as you see that if we don't have this term, we will have the linear first order equation where x is a function of t, and we have that term which makes it a Bernoulli. Right. Next, we have sine cosine here, so it's not going to help in terms of the Bernoulli equation, because we have the y inside the sine cosine. We cannot turn that into a power like this on one side. So it's not going to be the Bernoulli. And a homogeneous We have cosine and sine, and cosine and sine it doesn't have the degree like the power, so it's going to be no on the homogeneous also. Right. What we see is the linear coefficient, which it's not going to be that either. So always substitution, we're going to make z equal to for x plus y, and we go from there. So this is the type of equation that we're going to use the substitution.